Okay, my name is Matthew Livengood. This is the video for the first ANSYS project, where I'll just be showing the Poiseuille coed and the hybrid flow. So let me just get this loaded up. Okay. So I'm going to create my geometry here, then dimensions. So I'm going to make my height, let's make these into millimeters. I'm going to make my height 10 millimeters. And since the length has to be 50 times the height, that means I'll have 500 millimeters. So let's come in here and we'll just delete these markers. And here's our flow, or not our flow, our geometry. So I'm going to create a surface. And I'm going to select apply, generate. Okay, so there's my surface. Next, I'm going to mesh, and we'll let that load. Okay. So I'm going to start by doing this. Okay, generate. We're going to size. So I want to select the edge. This is going to be, so number of divisions, we'll say 150 and hard. Generate. Okay, then we're going to do the same thing for the top and the bottom. So top, bottom, number of divisions, we'll say 400, and we'll give it hard behavior, and we'll generate it. Okay, and then we need to do the face meshing. And generate. Okay, so as you can see now, we have a pretty tight mesh on here. Next, I'm going to need to name these. So this is my inlet. Outlet. Top wall. And bottom wall. So as you can see, inlet, outlet, top wall, bottom wall. Okay, so we're going to update our mesh and move on to the setup. So we're fine here. We're going to change the viscosity just to laminar. And we can go to our materials. And we're going to change the density here to 1. And then we'll have our viscosity changed to this. Then we'll go to our boundary conditions. Our inlet is a velocity inlet. For Poiseuille, we'll do velocity inlet. Hold on a second. Here we are. So velocity magnitude, we'll say 10 meters per second. Okay. Our top wall, let's just check. Stationary, okay. So let's just make sure here everything is okay here. 1, 10, and 0.0001. Okay. That should do it for this. So let's initialize. And we'll run it. Oh, gotta change this. Okay. Okay, so I'll come back to this screen once I finish Poiseuille. Okay. So we're going to call this velocity, or just velocity contours. So, oops, symmetry. We want to see our velocity, and give 50 contours. So let's just change our legend real quick. Horizontal, we'll make this size 1, and we'll make this 0.05 and fixed. So as you can see here, this is the Poiseuille flow. It's pretty centered. As you can see here, this looks exactly like the flow models that we draw. The velocity is greater in the center, and it decreases towards the edge of the at the edge of the walls because of the no slip condition, and the velocity gradually increases throughout the pipe until it reaches its max velocity. So next step is to, let's see here, we have to make a chart. But first, let's go ahead and insert a bunch of lines. I'm going to put 5 lines, 1 for every 100 since my length is 500. So, okay, so domains, that's okay, that's fine. So 0.1, 0.1, and my height is 10 millimeters, so 0.01, and we'll say 100 samples. So there we go. And then I just have to add a bunch of these. Oops. 0.2, 0.2, 0.01, 100. There's our second one. 300, 0.3. 2 more. our fourth one, and our fifth one will be at the very end. At 0.5. Okay, now let's create a chart. We'll call this velocity profile. So XY, we're going to say this is velocity, this is Y. Okay. So series 1, I'm just going to call this 100 millimeters. And we're going to get this from 100. So there we go. Add another one. 200 millimeters. 200. 300 millimeters from 300. Okay. 100 millimeters from 400. 500 millimeters from 500. And there we go. So as you can see, they keep getting closer and closer to each other because the velocity just increases throughout the pipe. Okay, so let's go back and I'll do Couette. So still laminar, but we're going to change our Reynolds number to 0.01. Boundary conditions. Inlet, we're going to change the inlet to a pressure inlet. Okay, and then we're going to give our top wall a velocity. I'm going to just give it 10 meters per second. Okay, let's change our reference value. 0.01, and that should do it. Okay. As you can see, there's a linear line forming in the x velocity, so that's a good sign. Okay. Okay, so as we see here, if we zoom in, the max speed is going to be at the very top of the pipe, and it's going to gradually decrease to 0 at the bottom because of the no slip condition. And let's just look at our chart. We should have a linear, linear chart. Okay, and we're going to go back and do the hybrid at this point. So we're going to change our Reynolds number back to 0.001. Boundary conditions, we're going to give our inlet an inlet velocity, and I will say it's 10. And then we'll change our top wall velocity to, let's say 2. Okay. Let's change our reference value, 0.001. Initialize. Run. Okay. So it resembles the Poiseuille flow, but as you can see up here, it's shifted, it's skewed off to the towards the upper direction of the pipe. And we can see the same thing here. It's somewhat subtle, but maybe I should have chosen a higher velocity. But you can see how the velocity contour is not in the center of the pipe anymore. It's skewed upwards towards the top wall of the pipe. So that is all three of the flows. Let's see, I think that's all. Thank you.